In the last lesson, we talked about the sine ratio, and today we're going to talk about the cosine and tangent ratio. The cosine ratio, as you might guess, with co meaning along with, is related to the sine ratio, where the sine ratio is a ratio of the side opposite an angle to the hypotenuse. The cosine ratio is the ratio of a side adjacent to an angle to the hypotenuse, and the tangent is the ratio of the side opposite an angle to the adjacent side. And we'll look at each of these separately. Using the cosine ratio is very similar to using the sine ratio. So if you are the master of the sine ratio, you are practically the master of the cosine ratio already. So we have the situation here. We have a right triangle. The hypotenuse, we don't know. It's designated as letter C. We know we have a 30-degree angle, and we have a 12-unit side. But the side that we know in this case is the side that is adjacent to the 30-degree angle. So this is the side opposite the 30-degree. Here's our 30-degree angle. Go opposite. That's the opposite side. But the side that is one of the rays of the 30-degree angle, that's not the hypotenuse. Here's the hypotenuse. Is an adjacent leg or an adjacent side. So we know that that is length of 12. So we're going to say that the cosine of 30, which we'll figure out on the calculator in a sec, is equal to 12 compared to C. And we can put this over 1, and then we can cross multiply to figure out what the value is for our missing letter C. Cosine of 30 rounds off to be 0.87, so we're going to say 0.87, and you figure out the same way that you would with the sine. You hit, turn on your calculator, clear it off, hit second, PRB, which brings up the trig functions, and then just scroll over to cosine. You'll go past sine, and then the opposite of the sine, and then you're at the cosine function, I think. It's pretty obvious once you turn it on and work with it. That's over 1 equals 12 over C. So we would know that 0.87 C equals 12 when you cross multiply, or 12 times 1. Divide both sides by 0.87, and you would get a value of 13.8 units, which is reasonable if you think about it. The hypotenuse has to be the longest side, and 13.8 is certainly longer than 12, and it's a pretty small angle. So the more acute this angle is, then the closer the hypotenuse, the length of the hypotenuse comes to the length of that adjacent leg. So let's take a look at an example where we know the hypotenuse, but we don't know the adjacent leg. Okay, here we have a right triangle that has a 10-degree angle. And by the way, you could easily figure out the measure of the third angle. You know this is 90. And you know that together the three angles add up to 180, so 90 and 10 make 100, which means this other angle is an 80-degree angle. Just to review that idea, but we're not going to, we don't really need that here. We're going to go ahead and say the cosine of a 10-degree angle, and I forgot to mention cosine is abbreviated COS, so that's typically how you'll see it read. And cosine of a 10-degree angle would be the comparison of 20 as the hypotenuse, and the adjacent side is A. And this is actually an easier problem to work with. Cosine of 10 degrees to the nearest hundredth would turn out to be 0.98, and that would equal A over 20. And when you cross multiply, you actually get the answer. You do 20 times 0.98 would equal A times 1. So A is going to equal the product of 0.98 and 20, which rounds off to be 19.7. So that would be 19.7 units, which is pretty close to 20, but still the hypotenuse has to be the longest side it is. If in this very acute angle, the adjacent leg and the hypotenuse are going to be very close in value. So that's a reasonable answer. Now let's take a look at tangent. Tangent is the ratio of the length of the leg opposite angle A. And I had to abbreviate to get this in here. This is opposite of angle A to the length of the leg adjacent to angle A. Okay, let's see how that fits in with this given right triangle that has an angle of 50 degrees, 90 degrees, and then we can figure out that the other angle is a 40-degree angle. But we started with given a 50 and given a 15. So we don't know the hypotenuse, but we do know an angle and we know side opposite that angle. So if we wanted to figure out what the other leg is, let's call this leg A, we could use the tangent ratio, which would tell us it's the ratio of the side opposite the 15-degree angle to the side which we're trying to figure out, which is A. So if I figure out, and to do tangent, you're going to have to hit shift or a second, then the trig function, and you're going to have to scroll over. I think you have to hit the scroll over to the right button 4 times. You won't see tangent at first, but it'll soon appear on there. So you enter tangent to 50 degrees, and you're going to see the value for that is 1.19. So 1.19 times A, when I do cross products, would equal 15. And then to figure out what A is, I'm going to have to divide by 1.19. Divide both sides by 1.19. And we would see that A, as I'll punch it in here, equal to 12.6. Yeah, reasonable, because another characteristic of triangles is that the length of sides are proportional to the size of the opposite angles. So this is a 90-degree angle. The side opposite is going to be the longest side of this triangle, and it's the hypotenuse certainly is always the longest side. But the side opposite the 40-degree angle is going to be smaller than the side opposite the 50-degree angle. If you think about it, it intuitively makes sense, because this opening here is larger. I'll just color that in. That opening is larger than this opening of 40 degrees, so this is going to have a smaller side opposite. So that's how the tangent ratio works.